All right, there is one more, I promise, the last one. One more type of problem that I will go over with you in this 2.1. Last thing I want you to do here. So we've gone over so many different types of problems. This is one where we're taking 1 over 1 plus sine theta, and we want to try to write it as a non-fraction. Get rid of the fraction. Okay, so kind of a weird one, right? You're not adding any fractions together. You're not factoring. You're not, changing things to sines and cosines. We're just trying to make this not a fraction. Now, what we're going to do, in order to make this not a fraction, we're going to multiply by the conjugate. This is a very common practice in algebra. Multiplying by the conjugate has some special properties that when you multiply the two conjugates, that simplification happens. This is what I mean by conjugate. For example, on the left, if I have, let's just say, x plus 1. X plus 1 is a binomial, two terms. The conjugate of x plus 1 is just x minus 1. It's the same terms, but I changed the plus to a minus. Or if it was a minus to start, I would change it to a plus. These two are conjugates of one another. And if you were to multiply these together, okay, it correlates to the difference of two squares pattern that we saw. Okay. But if you were to multiply this together, so, watch what happens. You're going to multiply x times x and x times minus 1. We get x squared minus 1x. X squared minus 1x. And you continue to distribute, and you get 1 times x plus 1x, and 1 times negative 1, minus 1. Okay, so when you multiply two conjugates, this similar thing always happens. Right, the middle terms here, negative 1x plus 1x, those cancel. Those go away completely. So my answer is x squared minus 1. Right? This looks familiar. This should look familiar because if I wanted to factor this, which is the difference of two squares, it always factors to this. But if you go the other way and you multiply by two conjugates, okay, kind of the result of factoring difference at two squares, you would always go back to something like this. Okay? Now when you multiply by conjugates, this helps us in a lot of places where we need to simplify. Okay? It's not going to just happen with this problem here. In other classes, in other situations, multiplying by a conjugate can be useful. Okay? So here's a case where we do it, right? I'm going to multiply the bottom of this fraction by the conjugate. The conjugate of 1 plus sine is going to be 1 minus sine of x. When I multiply those together, something's going to happen that's nice, right? Things are going to cancel off. Now I have to do that to the top as well, so I'm going to multiply the top by 1 minus sine x. Okay, these are conjugates right here. 1 plus and 1 minus sine are conjugates. So let's go ahead and see what we get here. If I first multiply the bottoms, let's just focus on the bottoms there. Let's put that in green. Okay, 1 plus sine times 1 minus sine. Let's just do that. If we multiply that out like we did on that little example, we would have 1 minus sine, and then we'd have plus sine x, then minus sine squared x. So you multiply that out. Now it's always going to happen where some of these terms cancel off, right? This is going to cancel. That's going to go away. Minus sine plus sine is going to go away because that equals 0. Right, so what are we left with on the bottom of this? We're left with 1 minus sine squared x. Now let's take this a step even further. take this a step further. What is 1 minus sine squared x? Think back to your trig identities, right? Think back to the main one. Sine squared plus cosine squared is always equal to 1. And I can fit a little puzzle piece here. 1 minus sine squared. I can use this, and we can just subtract a sine squared to both sides, like we showed earlier. And on the right-hand side, then we get 1 minus sine squared is equal to cosine squared. So we have this happening. There is a puzzle piece I can fit right in there. 1 minus sine squared, 1 minus sine squared is right there. So that equals, and eventually you do so many of these that you realize, oh, you just got to remember this, right? 1 minus sine squared is cosine squared. So I'm going to make that substitution. Okay? Great. All right. So we multiply by the conjugate. We multiply this out, and eventually that leads to just taking this and giving us cosine squared. Okay, that's nice. On the top, right, now let's think about what happens on the top. All right, so that I'm going to put this, I'm going to gray all this out. The top here, 1 times 1 minus sine. Well, nothing really spectacular happens there. That's just 1 minus sine. So we're going to bring this over and say 1 minus sine of x. Okay? So this is what we got, right? We have 1 minus sine x over cosine squared x. And you're like, how in the world? That didn't even help. Okay? I'm supposed to make this turn into not a fraction. And I'm doing all this crazy algebra to try to make that happen, right? I multiply by the conjugate, and now I'm here. And you're like, well, I still have a fraction, right? If we go a step further, we can make this happen, right? So think about this. So what if we take this and we kind of break it back down? We kind of decompose those fractions, kind of like the opposite of adding fractions, like breaking them back apart. So I could write this as 1 over cosine squared x, right, minus sine x over the same thing. And that would be like, that would be like the step usually that we combine the fractions to get to this. What if we go backwards and we break that up again? Well, this could do the trick. Now, because if we think about what is 1 over cosine squared, that is secant squared. So we'll write that as secant squared x. Then we can think about what is sine over cosine squared. This is a little different. Let's, because there's a squared there, we can't just say that's tangent. So let's write this as the sine of x. Instead of saying cosine squared x, let's write this out and actually break it up again and say cosine x times cosine x, right? Because cosine x times cosine x is definitely cosine squared. And let's even I'm going to put a 1 here just so you can clearly see what I'm about to do. So now you could treat this as 2 separate things. I'm going to put this in green. We know that sine x over cosine x, that's tangent, right? This is tangent x. We know that this 1 over cosine x is equal to secant x, right? So I'm going to say times, or just secant x there. That's what that becomes. I'm going to bring down this secant squared x minus there, and this is what this becomes. Okay? So technically, we have done a lot. We did what it asked for. We had a fraction here, and we rewrote it so that it wasn't a fraction. It was an expression here. You might be thinking, man, that doesn't really look that much more simple. Like, you didn't really simplify. And I would say this is the one that is out there more, right? Because it's a lot of algebra, it's a lot of juggling around and switching around these pieces, which when you get to the end, it almost doesn't feel as satisfying. It's not like, it doesn't feel like I've accomplished much. Sure, I didn't make it a fraction. Now it's not a fraction. But if you can do something like that, right? The new skill that we introduced here is multiplying by a conjugate. You'll see that a lot in a lot of other contexts. So multiplying by a conjugate and then breaking this up and still using those puzzle pieces to solve and to take this, right? To use a Pythagorean identity right there to get this right here, and then breaking it up into separate fractions and saying this is secant squared, and then getting to this answer. That's really good if you can go through all those steps. So there was your bonus question of the day.